So, my name is Luke Schwerdtfeger. I was funded by GAUSSI this year. I'm going to talk to you today about intestines, how people used to study them, and how we study them now in the total lab. So, 70 million people this year will go to a physician for a GI issue of some sort. That's just in the United States, not even globally. That is a massive amount of our population who go for a GI problem. And you often probably don't think about your GI tract until you really have to think about your GI tract, and that's not something a lot of people enjoy. So I originally set out wanting to figure out how the gut actually works at a baseline level, because we don't know a ton about it. And it turned out that everybody under the sun was doing pretty much one of things, which was transwell cultures, and then eventually shifted to organoids. Now, transwell cultures are single cells put out onto a permeable membrane. You can test things that go through them, test how they respond to drugs. Organoids are essentially the exact same thing, just propagated. So they take a stem cell that can actually turn into a bunch of other cell types, and you end up with this little ball of intestine chilling in a dish. The other one is a lab on a chip, or a gut on a chip. Came out of the Beast Institute originally in 2007. They essentially take a transwell culture and put flow on it to get it to make a little villus. The problem is that none of these methods up here have anything besides epithelial cell types. There's over 20 cell types in your intestine, epithelia being one of them. So I set out to design a system that has more cell types, essentially. So we have microbiome, we maintain it, we have epithelial cells, we have neurons and glia, we have immune cells, we have musculature, all of the above. The other fun part is we can keep it alive for 6 days, which anyone who does cell culture will scoff and turn their nose at. But in the world of tissue culture, that's 6 times longer than anybody else can do that. So we're really excited about that. So the reason this is important is we can study all sorts of interactions that aren't available in those transwell cultures. For instance, some of our newest data is showing that we're actually having a neuronal mediation of the immune system in these slices. Now, hopefully this will play. Yeah. So that's an intestinal slice in a dish at, and it's a little dark, sorry, but at 2 days ex vivo in the dish. Glowing in there is enteric neurons. So you have an extremely vast nervous system in your intestine. Now, so we can study all sorts of these things in a dish. The big problem, though, is trying to get essentially a culture shift in the world of gut study. I've had multiple reviewers and even a reviewer for a review paper kind of scoff at the idea that I was doing ex vivo slices like this instead of just doing cell cultures. And we need a culture shift, so I'm always looking for collaborators that could use my model for drug discovery or other things like that. Thank you.